and there is a section Open and Replications, and you can see here Open and DSS synchronous replication over a LAN, which will guide you step by step how to set up the volume replication between two DSS systems. This guide is quite useful. There are many tips how the volume replication should be set. For example, we strongly recommend to use the dedicated connection for volume replication in order to achieve the best performance, and some additional steps as well, how to instruction. Okay, so we'll set up the volume replication using our 2D SSS. I have to set up the volume group on both units. And for the test purposes, I will create a small volume, about 15 gigabytes to make this webinar shorter, because volume replication to sync all the data from the primary to secondary at the beginning. So when using 10 gigabits Ethernet, it should be quite fast to get them synchronized. The volume group on the primary unit is almost ready. We are creating iSCSI volume. I will create additional target for this, because we will be using in next steps Windows system and iometer. And we need to select use volume replication for this volume. We are using block IO volume, and the size of the volume will be 15 gigabytes. The same size must be on the secondary unit. The volume replication only works when both volumes, the source and the target, are exactly the same size. I don't need a SYSCTL volume here, so I will not create one. I need to select this volume replication as well, and the size of the volume. At this stage, I have two volumes created. I need to switch the volume replication mode on my secondary unit. As you can see here, we have a source and destination. We'll use this one as a destination server. So I'm changing to destination mode. This one is correct, and by default it's created with the source mode. Another thing is that I need to put the mirror server IP in both nodes in order to power the servers. I may check what kind of IP I have set on the interface using the status network. And we will be using the ETH7 on this node for communication. And from the secondary node, we will use the ETH9 interface. As you can see, it's in the 192, 168 free subnetwork. So in mirror server IP field, I have to put the IP of the secondary server here, and the same step must be done on the other node. Now when the mirror IP has been built, I may create the volume replication task. I will call it P1. In the source volume, I'm selecting the source volume of the replication. In the destination volume, I need to select the destination volume on the other node. In this field only on destination volume, only volumes that are listed are those ones that have the same format and the same size as the chosen source volume. Bandwidth for sync source, I can put here max, what is available for DSS, it's 60 megabytes per second. This value only takes place during the first synchronization, when the data are being transmitted from the primary node to the secondary node. Then when both volumes are consistent, so contains exactly the same data, this limitation does not take place anymore. So as you can see, I have a volume created, so I may start. At this stage, I must check the volume replication status. Both volumes, when we are using block I/O, are consistent immediately. In case we did not make any modification to data on the source volume, so we just created two volumes that were empty. So they are consistent from the beginning. We have created also SYSCTL targets together with creation of SYSCTL volume, and you can check here that the created logical volume has been added automatically to the SYSCTL target. At this stage, we'll check what performance we can achieve using the Windows and I/O method. So I have prepared some connection to remote Windows system that has also built-in 10 gigabit interface. So we just need to connect to the target. I already added the target to our forecast groups, so I just need to log to the volume. After adding the SYSCTL target, I have to initialize the disk. And right now my disk is available for Windows. I did not create the file system, as the file system has an impact on the performance, so we'll be using for test the raw device, which is always faster than the volume with the file system. So I'm using I/O method that already has been installed on this machine. I have here 12 workers because my machine is 12 CPU cores. I will choose the physical drive. Let's choose this for all workers. And we'll create the new access specification test. It will be 1 megabyte per percent sequential write. So I need to change parameters here. Set to 100% write and 100% sequential. I am assigning this to the main machine and starting the test. As you can see, without any tuning with the default options, our performance is a bit better than 200 megabytes. It's around 250 and 30 megabytes. Right now we'll focus on how to tune the DSS, the network, the DFBD, and other things to achieve the best performance. First, what we need is to install small updates that were prepared by our support team. The small updates add you the possibility of tuning SYSCTL values. It's the special tool that allows you to tune some low kernel level values to achieve the best performance, to get lower latency time, and so on. And we need to go to the maintenance software update to the web GUI, and in the system software update tab, we need to choose the file we would like to update. I have the file already uploaded on my desktop, so I'm choosing upload. After uploading, I can see the release notes of the small update. It's called SYSCTL, as well as the small update contains network test tools based on NUTTCP tool. So I need to accept, and after accepting the small update, we need to reboot for the changes to take effect. So we are rebooting the server right now. Before I have already applied small updates to the secondary system, so when we will be waiting for the primary system to come up, we will be making tuning to the secondary system. And here I have the console. Those two new functionalities are added to the console tools, to the add-on section. So we need to go to the Ctrl+Alt+C, and we have a option add-on, and we can here see two new options. It's SYSCTL and TCP network. About SYSCTL tuning, most information are very easy to find on the internet. If you will go to the Google, for example, and you will put 10 gigabit Ethernet Linux tuning, you will get many kind of guides how to tune parameters to get the best performance. Some of them differs a bit about some values, but mostly they are about the same. I will choose this one, and we'll be tuning those values in the SYSCTL. So I'm selecting the tool called SYSCTL tuning. We get the information that it can be dangerous, so it is designed for experienced system administrator only. Something went wrong, sorry. Unfortunately, something does not work for me here. So maybe I will check if this system is already up. I think we'll try to reboot. reboot the server, this one as well. wait for this system to come up. You can use ping to see if the system interfaces are responding. Okay, our interfaces are up. We'll have to wait for the other services like Apache to start. Regarding those parameters, as I said before, some documents, some information that you can easily find on the internet differs, especially about no metric safe parameter. There are someone telling that this parameter gives better performance when it is enabled, someone that it should be disabled. But from my experience, I would say that it gives better performance when it is enabled, because the interface doesn't have to store additional information, doesn't have to send additional information. Okay, our system is up. Login. And you can connect to the console here. Okay, this page will go to the other section. Unfortunately, something went wrong with the small update, so please accept my apologies. I will need to check that. We will focus on other tunings. What is the most important when you have a 10 gigabit connection between two nodes is the NQU, other call this jumbo frames. By default, the 10 gigabit Ethernet does not use jumbo frames and uses NQU with size 1500. But when we'll tune that and we'll enable jumbo frames, the performance will be much better. So in order to tune the jumbo frames, we need to go to the Ctrl+Alt+V W, and we have an option called tuning options, and we have a jumbo frames config. We'll enable jumbo frames for all 10 gigabit interfaces we have in the system. We'll use the value of 9000. Please be aware that the frame size you are using here must be supported by all your devices in the network. So if you are using, for example, 9000 frame size here, and there is a switch in between, your switch must support this value as well. And the same frame size should be set in all interfaces using this subnetwork where the tuned interface is. I have direct connection, so I'm using 9000 frame size. Okay, the first node has been tuned. We have to wait for the other to come up. The other is not yet, so we'll have to wait a bit. What else we have here is the DRBD tuning. The DRBD is the driver used by volume replication, and This is a driver from kernel space and has also some additional parameters that should be tuned regarding to your environment and regarding especially to your hardware. Some hardware behaves better with smaller values, some hardware with better. When you will put to Google a DRBD tuning, you will get as the first link is the tuning recommendation of DRBD, and it's a very interesting document saying how to find the best values for your environment and for your hardware. We have a few things to tune here, but the most important from our point of view are max buffers and max epoch size, as well as disk barrier and disk flashes. But be aware that those values should be disabled only in case you have a write controller with a battery backup, because in case of failures it can lead to loss of data. Our write units here are equipped with a DDU, so we can disable those additional functions used by DRBD to ensure that data are safe. So we'll increase max buffers to 8,000 and as well as max epoch size. And we will disable no disk barrier and no disk flash. And we need to apply. The same we'll try to do on the other node. So we'll enable jumbo frames on all devices, on all network interfaces. We'll use 9,000 here as well. And we will tune the DRBD driver. So we use the same values here. It's 8,000 for max buffers and 8,000 for max epoch size. And we will disable additional safeguards of DRBD. Okay, after that, we need to run the volume replication again. What you will notice is that the volume replication task has been disabled. It's because we did changes to the disk barrier and disk flashes, and it requires to clear the metadata to start the replication working again. So we'll clear the metadata on both nodes. And we will start the volume replication task. Those tests are recommended to be run before getting the system to live production during the test phase, because changing those values will require the resyncing of the data. In case of big volumes, it can take some time. So those values should be found for the system before the system is in live production. As you can see now, the volume replication is running. As there has been some changes to data, we need to wait for the replication to become consistent. If I will start some write test right now, the performance would be very slow because the volume replication has the higher priority. So it's the most important thing is to have the two volumes consistent before we will put new data to them. So I can show you that if I will start the iometer right now, the values are much slower than before because the volumes are being replicated right now, and until they become consistent, our write performance will be limited. So we have to wait for another about 30 seconds, and our volumes become consistent, and then we can run some additional tests. What is important also before we will start tests, so we have tuned the 10 gigabit connection that is used for SYSCTL as well, because our Windows system is connected to SYSCTL over 10 gigabit as well. We should tune the 10 gigabit interface on the Windows. Especially we should set the jumbo frames. So we'll go to the network sharing center. I'm choosing the 10 gigabit interface. Go to configure, advanced, and here there is an option called maximum transmit unit. It's 10,000. I already set it to 10,000. So right now the connection between two DSS nodes is on the 10 gigabit interface with jumbo frames, and between Windows and primary node of DSS also using jumbo frames. Our volumes became consistent, so we can right now run the tests. I'm starting the same test with the same values. Stop the test. Select the workers. Okay. Right now, we have even slower performance, so we need to find what exactly happened. I think I know. We only tuned max epoch and max buffer size, but if we go to the DRBD tuning recommendation, there is also another tweaking option. It's called unplugged watermark. And this value is mostly dependent on the I/O subsystem controller, so your write controller. And for some write controllers, as it's stated here, the max performance will be with smaller value. But for some, the max performance will be with the same value as max buffers. So we'll try to tune the unplugged watermark value on the volume replication DRDB driver. Before we do so, we have to stop the volume replication task. And we can tune this on both nodes. We go to DRDB again, and we'll put the unplugged watermark to the same value as max buffer. And the same we have to do on the other node. So we are using 8000 on both and applying values and starting the volume replication task. You can check the consistency before starting the test. As you can see, volumes are consistent immediately because there were no changes to data, and we are rerunning the test. It did not impact the performance much, so we are going back to our document and we will try to find why the performance is slower. So we go back to the tuning recommendations, and we have also another tune parameter. It's called rExtend, the activity log size. And it says that if the application is write intense and our test is write intense, we can increase the activity log to get the best performance. So again, we'll go to the volume replication task and we'll stop it. And try to change the volume of our extents. The max value here is 3389. Okay. So I will try with this value. And the same steps we have to do on the other node. After that, we are starting the volume replication task again. And we are checking the performance. As you can see, this time also did not help. We still have the performance at the 100 megabytes level. So we need to find some additional tunings how to improve the performance. We are going back to our documents, and here we have also some parameter that is auto-tuned by default in DSS. It's called send buffer size. By default in DSS, its value is 0, which stands for auto-tune. But we can try to force the send buffer size of the value we would like. The document says that for most, in the most cases, the 2 megabytes is the best, and higher than 2 megabytes are generally not recommended and unlikely to produce any true output improvement. So again, we have to stop the volume replication task and we'll try to tune the send buffer size. We'll check to 2 megabytes, it's 2048, apply, and the same we have to do on the other end. Okay, it's set to 2 megabytes, and we are starting the volume replication task. So what we can do now is to start the IO method test again. It did not decrease the performance again much, but just a bit. So still we have to find what is the bottleneck here and how to make it working faster, not slower. Some additional parameters. What we can do, we can also check if we did some mistakes. Maybe we put wrong values for MQ. So I will go again to jumbo frame configuration and we'll check if 9000 is set in all cases. On the first node it is, and also on the other node. Okay, and sometimes also happens that the volume replication requires to clear the metadata after making changes, because it stores in its metadata some kind of information and they were not updated. So we'll stop the volume replication task. We'll clear the metadata on both nodes. And we'll start from the beginning. So we have to do the full resync again. As you can see, the sync speed between two nodes is over 600 megabytes. So we will need to wait again for the full sync between volumes, and we'll start the test from the beginning. On the other hand, the reason for the slow connection can be also the iSCSI target in this case, because we have tuned the connection between nodes, but we did not tune the iSCSI target values that can also can be bottleneck here. So if you will go to our knowledge base, it's kb.open/e.com. And there are many interesting articles here about what we need to find is SYSCTL tuning. And the first article we will find is about how to tune the SYSCTL target. It was written when there was some command abort, but those recommendations here are good also for achieving the best performance between SYSCTL target and SYSCTL initiator. So in order to tune that, we have to go to tuning options on the primary node, because only here we have SYSCTL target, SYSCTL daemon options, and here is the option called target options. We select the target we would like to tune, and we are changing the values here. So we will put here 64 kilobytes for max receive data segment length. This will cause a short drop of connection for SYSCTL, but most of initiators should handle that, and after a while the target will be available again. Also, we'll increase the max burst length to highest possible value. As you can see in the document 16776192. And also max transmit segment length to 64 kilos. What more we can tune is the max outstanding ready to transmit. This value is recommended to increase in case of write intense application, for example, databases. When you have some databases on the SYSCTL target, it's recommended to set it to 8 or even 16, but we will use 8. So our target will be able to wait for some commands in the queue. So by default it's set to U1, so each command is executed simultaneously, but if we will increase it, it can be stored in the memory and waiting for its execution. Okay, so we have tuned our SYSCTL target. And our volumes become consistent, and we can go to the Windows and to the iometer and run the test again. We need to wait a bit until the Windows will see the target again. As you can see, we are getting much better values after all the tuning we did. At the beginning we had about 250 megabytes. Right now we are almost at the same level as the max write speed on the secondary volume. So in our case, the only bottleneck right now is the performance on the secondary write volume. If you have any questions, please just use the chat and I will try to answer. I saw that there are some questions. Where can I download the small update? If you want to get the small update, you need to send the email to the support team or to the email you got the webinar invitation, and all materials used here are available to download. This also might apologize for not working the SYSCTL tool. It was working about an hour ago, and I have to check exactly what happened. Can you send me the parameters for the SYSCTL target? Yes, of course. You can find it on our knowledge base. It's kb.open/e.com, and you can find, there is a search and just put iSCSI space tuning, and you will get all the information how to tune the SYSCTL target. I may send you it using the chat in the viewer. Can we go more than 100 megabytes per output? Yes, of course. As I said, the only limitation is your network, and if you will tune your environment properly to your hardware, the DRBD overhead can be something like up to 10%. So in case you have right performance on your right controllers at 1 gigabyte per second level, you may achieve something about 900 megabytes or even more with volume replication task enabled. Also mail us all settings parameters set by step. There will be a knowledge base document as well as a solution that can be found on our website openin.com. If you go to support, library, to how to resources and to solutions, there will be a document saying about those parameters, about about how to find the best parameters for your environment, for your hardware. Because as I said before, it's most of DRBD, for example, parameters are hardware dependent and must be tuned individually.